Hello. In this example, we're going to graph f of x equals negative x minus 1 times x minus 3 times x plus 2 squared. Now, normally when we're trying to graph, the first thing we would do is we would find all possible rational zeros. However, this time we won't. And the reason we won't here is because we know what the zeros are, but just by looking at the problem. So what we're going to do instead is we're going to go ahead and write down our table, the zero, the multiplicity, and the behavior. If I can somewhat spell. Okay. Now, because this function is fully factored, and every factor is x plus or x minus, the zero is always the opposite of the number that we see here. Because in order to see this, what you can do is you can set x minus 1 equal to 0. Add 1 means x equals positive 1. So positive 1 is the 0. So positive 1 is a 0. Same thing here, you would say x minus 3 equals 0, add 3, so x equals 3. And when x is 0, or when this is equal to 0, that means x is negative 2. So that's your 0. And then the multiplicity. Remember, the multiplicity is the exponent on the factor. And the exponents we see here are 1, 1, and 2. And yes, those are understood because they're not written. So you're going to put a 1 here, a 1 here, and a 2. And the behavior, remember, if it's an odd degree, it crosses, and if it's an even degree, well, multiplicity and degree of the factor there, it bounces. So for the multiplicity 1, it crosses. For the multiplicity 1, it crosses. For the multiplicity 2, it bounces. Fantastic. Now the next thing we're going to need is the y-intercept. And when we do the y-intercept, this is actually the most difficult part of the question. So if I do f of 0 here, what this really means is negative 0 minus 1 times 0 minus 3 times 0 plus 2 squared. Then you simply simplify it. So that gives you negative times, well, negative times negative 1 times negative 3 times 2 squared. And 2 squared is 4. So there are 3 negatives, which gives me a negative here. 1 times 3 is 3 times 4 is 12. So that means that my y-intercept here is 0, negative 12. The next thing we're going to look at is the end behavior. Well, again, if I can possibly spell something correctly, that would help. The question becomes, what is the degree of this polynomial? And the degree is simply the sum of the multiplicities. 1 plus 1 is 2, plus 2 is 4. So this is a degree 4 polynomial. And because it's a degree 4, that means that the end behavior is either going up in both directions or going down in both directions. And it all depends upon the leading coefficient. And the leading coefficient here is a negative. So it would be this, going down to both directions. So the end behavior looks like this, down to the left and down to the right. Notice it goes to the same direction. Now all we do is we graph. So plot the 1, plot the 3, and plot the negative 2. Notice it's going down to the left and down to the right, and the y-intercept is 0, negative 12. Now this only goes down to 10 for me, so I'm just going to kind of estimate where the 12 is, somewhere about right there. Okay, now look at the negative 2. It bounces. So we're down here already, so it's going to look something like this. And then it's going to go back down to the point here and then go back up to this 0, and at 1 it crosses to the other side. And then it's going to come back down and hit the 3 and it crosses again. Fantastic. Everything lines up. So just kind of connect everything. Good. Now obviously this is not a great graph, and honestly if you were to be picky about it, it's not even a function. But I'm not looking for great graphs. I'm looking for, are the zeros correct? Are the behaviors at the 0 correct? Is the y-intercept correct? And is the end behavior correct? And can you try to avoid doing this? Now, it's kind of hard to not do something like this on the computer, but try not to make it look like not a function. It's a little bit weird that way. Alrighty, well, I will see you next time. Have fun.